Hey everyone, welcome back to the channel. In today's video, we're going to learn how to write dynamic queries using the Criteria API in JPA. Now, if you're wondering, what exactly is the Criteria API? Well, the Criteria API is a feature of JPA that allows us to build queries using Java code instead of writing raw SQL or JPQL strings. It provides a programmatic and type-safe way to create database queries, using classes and methods rather than plain query strings. So instead of writing a query like a string, you construct it step by step using objects, making the whole process more structured and integrated with your Java code. Alright, now this is where things get really cool. With Criteria API, we're not messing around with those fragile string queries anymore. Instead, we build our queries dynamically using Java objects. That means we can avoid those annoying string-based query errors, like typos or mismatched fields. And the best part? It works directly with our JPA entity classes and their attributes, so it feels just like writing normal Java code. I know, you're probably getting a little bored with all this talk. So let's spice things up. Enough theory, let's jump into code and see Criteria API in action. Ready? Let's go. Alright. See on my screen, we're running a simple select asterisk from employee query. Now, our goal is to run this exact same query using the Criteria API. So let's switch to IntelliJ and start coding step by step. Let's do this. See my screen. Earlier, we used a JPQL query to fetch all records. Now, we're going to do the same thing using the Criteria API. So let's create a new method called findAll3. Okay, so now we want to write our query using Criteria API. The first thing we need is a criteria builder object. Remember, make sure you import it from jakarta.persistence.criteria package, not from anywhere else. Think of Criteria Builder as our query builder helper. It helps us create all parts of the query step by step using Java code instead of strings. You might be wondering, how do we get this criteria builder object? Well, the Entity Manager provides a handy method called getCriteriaBuilder for this. It returns the Criteria Builder instance we need to start building our criteria queries. Alright everyone, take a look at my screen. Here we have the Criteria Builder class. Now this thing is loaded with a huge list of methods like createQuery, and or equal, like, and so many more. It's basically a complete toolbox to help us build queries dynamically and safely. But here's the thing. If I start explaining every single method right now, it's going to get overwhelming and super long. Plus, you might lose track of what's important for the task at hand. So, instead, I'll focus on just the essential methods that we're going to use in this tutorial. That way, you can see clearly how these methods work together to build queries, without drowning in details. I want you to get comfortable and confident with these basics first. Once you understand these, exploring the rest of the Criteria Builder methods will be much easier when you want to add more complexity later on. Ready? Let's move on and start coding. See, the Criteria Builder provides this handy method called createQuery. Now, this method needs to know what type of data you want to fetch, basically, which entity or table you're querying. So, you pass the class of your entity to it, like employee.class. This tells Criteria Builder, hey, I want to build a query that returns employee objects. And what does it give back? A criteria query object. This represents the structure of your query and defines what kind of results you expect. Think of criteria query as the blueprint of your query, where you'll later specify conditions, joins, sorting, and so on. See, Criteria Query provides lots of useful methods to shape your query exactly how you want it. You can specify what to select, add conditions with where, define sorting with order by, and even set grouping if needed. Alright, this select method is used to tell the criteria query exactly what data you want to fetch. Think of it like the select part in SQL. You can specify which columns or entities you want to get back. For example, if you want to fetch entire entities, you'll select the root entity. Or if you want just specific fields, you can select those too. So basically, this method defines what will be returned by the query. Now, multi-select method is like the advanced version of select. It lets you pick multiple fields or expressions at once, kind of like selecting multiple columns in SQL. For example, if you want to get both the employee's name and department together, you can use multi-select and pass those fields. This is super useful when you don't want the full entity but just specific parts of it. Now this one is basically the same as the previous multi-select method. But the difference is simple. Instead of passing multiple selections as separate arguments, here you pass them as a list. Next up, the where method. It is used to apply conditions in your query, just like the where clause in SQL. For example, if you want to filter employees where department is developer, you'd build an expression for that condition, and then pass it to this where method. This one is quite similar to the one we just saw, but with a key difference. Instead of passing a single condition, here we can pass multiple predicate conditions directly, separated by commas. It's super useful when you have more than one filter to apply, like employee name, department, and maybe even salary. And yes, all these predicates are automatically combined using and logic behind the scenes. As the name suggests, this method is used when you want to group your query results by one or more fields, just like we do with group by in SQL. For example, if you're building a report and want to group employees by department to calculate counts or averages, you'd pass the department expression here. You can even pass multiple expressions, and it will group by all of them. This is just like the having clause in SQL. It's used after grouping, when you want to apply a condition on the grouped results. For example, suppose you've grouped employees by department and want only those departments that have more than 5 employees. That's where having comes in. This is just like the order by clause in SQL. It lets you sort the results, either in ascending or descending order, based on one or more fields. You don't directly pass a column name here. Instead, you use the criteria builder to create an order object using ASC, or desc, method. This works just like the distinct keyword in SQL. When you pass true to this method, it tells JPA, "Hey, I want only unique results. No duplicates allowed." This method is used to retrieve the list of ordering conditions you've applied to a criteria query. This method is used to fetch all the parameters that have been defined in your criteria query. This method in criteria query is super important. It defines the main entity/table that your query will work on. Think of it like the from clause in SQL. It tells JPA, "Hey, I want to fetch data from this entity." The method returns a root object, which represents that entity in your query. You use this root to specify which fields or attributes you want to select or filter on. Call the from method to get the root object. We need to pass the entity class. That means the class representing the table we want to query. So here, we pass employee.class because we want to query the employee entity. This tells the criteria API, "Hey, I want to start my query from the employee table entity." Once we have this root, we can select fields, add conditions, or join with other entities, all starting from this root reference. Got it? Without this, we can't move forward in building the query. Next, we need to build our select query. For this, the criteria query interface provides a method called select. This method takes a selection parameter. Basically, it tells the query what to select. Here, we pass our root object, which means we want to select all columns from the employee entity. In simple words, it's like saying, select everything from employee. And that's it, our query is ready. No complicated strings, just pure Java objects. Now, how do we run this using Entity Manager? See, the Entity Manager's createQuery method directly accepts our criteria query object. No need to write a query string, just pass the criteria query we built, and Entity Manager knows exactly what to do. Then we call getResultList to fetch the data, and all records are right there. See, so simple. First, we get the criteria builder from the Entity Manager using getCriteriaBuilder. Next, we create a criteria query object specifying the return type, in our case, the employee entity. Then, we call from method on the criteria query to get the root object, which represents our table. After that, we use the select method on the criteria query to select all columns from the root. Finally, we pass this criteria query to EntityManager.createQuery and call getResultList to fetch the results. Now let's connect everything. Switch to the controller. See, we already have this findAll API method that we created in one of our earlier videos. So now, simply call the new findAll3 method from our service layer right here. Alright, now let's start the application. Now open Postman. Hit the API. See that? We got the list of employees returned successfully. That means our criteria-based query is working perfectly. Now switch to IntelliJ. Look at the console logs. Here you can clearly see that the Entity Manager is creating and executing the SQL query behind the scenes, based on the criteria API setup we just wrote. And yes, this is the exact same query we intended. Select * from employee. Just like we saw earlier using JPQL, but this time, it's built dynamically using criteria API. Pretty cool, right? Next, we're going to run a query with a where condition. Let's say we want to fetch only those employees whose name is a specific value. See my screen. First, we wrote and ran the same query using JPQL, just to understand how it works in the traditional way. But now, we're going to build and run the exact same query using criteria API. Alright, now let's create a new method. We'll name it findByEmployeeName1. Alright, look at my screen. Earlier, we wrote a simple query using the criteria API to fetch all employees. Alright. Now we want to add a small condition to our query, like filtering based on the employee name. And if you notice carefully, the starting part of the query is exactly the same as before. We're just adding a where clause on top of it, that's it. Okay guys, now here's the cool part. Since the start of our query is exactly the same as before, we're still selecting from the employee entity, the main code stays the same. But this time, we want to add a condition, like, give me employees where employee name is something specific. So logically, with the criteria API, most of the code will be exactly the same. Only one small extra step will come in to add the where clause. Alright, now since the start is exactly the same as before, there's no need to rewrite everything from scratch. First, we get our criteria builder from the Entity Manager. Remember, This is our main helper to build queries in Criteria API. Next, we create a criteria query object, telling it what kind of result we want. Here, it's the employee entity. Then, we get the root of the query. This is like telling the query which table entity to work with. And then we select from that root. All these steps are exactly the same as our previous code. So what I'll do now is just copy this part of the code from before and paste it here as it is. Perfect. Now the next step is to add our filter condition. See my screen. The criteria query object provides a very important method called where. This is how we specify the where clause in our criteria API query. Basically, the condition that filters which records we want to fetch from the database. The where method takes one or more predicate objects as arguments. A predicate represents a single condition or filter in the query, like employee name equals something, or salary greater than X. Now, let's create a predicate. To create a predicate, we use the criteria builder, not the criteria query. See on my screen, Criteria Builder is super powerful. It gives us lots of handy methods to create conditions, just like in regular SQL. For example, methods like equal, like, greater than or equal to, and many more. These methods help us build the exact condition we need for filtering our data. Now, when we want to create a condition, all we do is call the right method on Criteria Builder, pass the field from our entity, like employee name, and then the value we want to match. So, now we want to check if the employee name is equal to some value, right? For that, we use the equal method of Criteria Builder. First, we need to tell it which column or attribute we want to compare. For that, we use the root object that we created earlier. On this root, we call the get method and pass the exact field name as a string, just like I'm doing on my screen here. The second parameter to the equal method is the value we want to match. Now on my screen, you can see the predicate we just created. When we call root.get employee name, it automatically translates to the column name in the database, like employee_name. Next, the equal method we used will be converted into the equals operator in the SQL query. And the value we pass gets bound as a parameter, shown as a question mark in the SQL, which gets replaced at runtime with the actual value. And now this predicate, the condition we just built, needs to be added to our select query. For that, we use the where method provided by criteria query. So we call criteria queried where predicate. And just like that, this condition gets attached to our query. Behind the scenes, it's exactly like appending a where clause after a select in SQL. So now, our final query will fetch only those employees whose name matches the one we passed. Okay, now let's execute this query. And the good news is, this part is exactly the same as before. We'll use the entity manager again and call the create query method, just like we did earlier. Pass the criteria query object into it, and then simply call .getResultList to fetch the results. That's it. Now let's call this method from our controller. See on my screen, we already have a findByName API created earlier. So no need to create a new one. Just call this new method inside that existing API. Simple. Great. Now let's restart the application. I'm going to hit the API and try to fetch details of an employee named Pankaj Kumar. Awesome. See, we got the response back, and guess what? We've got 3 records for Pankaj Kumar. Now let's switch to dbeaver real quick. Yep, here too. Exactly 3 entries for Pankaj Kumar. Now jump back to IntelliJ and check out the console logs. This time, you can clearly see that our employee_name filter has been applied in the generated SQL query. The Criteria API has done its job perfectly, filtered just the way we wanted. Great! Now let's take it a step further. So far, we've learned how to create individual conditions using the Criteria API, like filtering based on just employee name. But what if we want to filter using multiple conditions together? Like, get all employees where employee name is Pankaj Kumar and department is developer? That's exactly what we're going to do next. We'll learn how to combine multiple conditions using and, or, etc., just like we do in SQL, but this time using Criteria API. So let's jump in and write a query that filters based on both employee name and department. Let's code this together. Alright. Now let's create a new method for this use case. Name it find by employee name and department. This method will take 2 parameters, employee name and department. Now, as we already discussed earlier, the initial part of the query is exactly the same. We're still selecting from the employee table, right? So let's reuse that part to avoid repetition. Next, let's create our predicates. That means the conditions for filtering. Okay, on my screen, you can see the SQL query where I've circled the conditions for employee_name and department. Now, if we forget about the and for a moment, these are just 2 separate conditions, right? One for employee name and one for department. Later, in the SQL query, these 2 conditions are combined with an and to filter results matching both. The cool part is, we can do exactly the same thing with the Criteria API. Here's how. First, we create one predicate for the employee name condition. Then another predicate for the department condition. After that, we combine these 2 predicates. So now that we have the basic idea, how do we proceed step by step? Just like we discussed earlier, first we create a predicate for employee name. Let me show you exactly how. Call the equal method on our criteria builder object. For the first parameter, we use root.get employee name. This tells Criteria API which column we want to compare. The second parameter is the actual value we want to filter by, the employee name passed to our method. This creates a predicate that checks if the employee name equals the value we want. We'll do the same for the department predicate next. Simple, right? Now we have these 2 predicates, one for employee name, one for department. Next step is to combine them using and condition. Good news, Criteria Builder gives us a handy method called and exactly for this purpose. Call Criteria Builder and method. and pass both predicates as parameters. This will return a new predicate that represents the logical and of both conditions, meaning both must be true for a record to be selected. See? Simple. Now this combined predicate can be used in the where clause of our query to filter results matching both employee name and department. Now, call the where method of the criteria query and pass this combined predicate, employee name and department. Great! Now that our query is ready, it's time to execute it. Just like before, use the Entity Manager's createQuery method, pass in your criteria query object, then call getResultList to fetch the results. Alright, see on my screen, step by step we did this. First, we created the employee name predicate using criteria builder to equal, passing the column using root to get, employee name, and the value. Then we created the department predicate the same way. Once we had both conditions, we combined them using criteria builder and method. Remember, to build conditions, we always use criteria builder. It gives us all the handy methods. And finally, we pass this combined predicate to our criteria query where method. So yeah, all the condition logic is handled using criteria builder, and the final query gets the filter using where on criteria query. Alright, now let's quickly create a REST API to expose this functionality, so we can test it easily through Postman. Now let's restart the application. Alright, let's hit this API now. I'm going to search for an employee with name Pankaj Kumar and department developer. See, we got the results. Both entries for Pankaj Kumar who belong to the developer department, just what we expected. Now let's open IntelliJ and take a quick look at the console logs. See this? This time, the SQL query behind the scenes has a proper where clause with both conditions, one for employee_name and the other for department, joined with an AND. Alright friends, let's pause here and continue in the next video. I know this one got a bit long, but we covered some really important concepts today. We learned how to use the Criteria API to create dynamic and type-safe queries in Spring Boot. First, we fetched all employees using a simple select asterisk from employee. Then, we added a filter based on employee_name. And finally, we combined multiple conditions using and filtering by both employee_name and department. This is super useful when you want to build flexible, readable, and maintainable queries without writing raw SQL. Thank you so much for sticking around till the end. If you found this helpful, don't forget to subscribe to the channel. Smash that like button to support this content. Drop a comment if you've tried Criteria API before, or if you're planning to use it now. I read and reply to every single comment. Alright, I'll see you in the next video.